Okay, year 10, so I'm going to try and go through these answers on a video. Let's look at question 1. This is using Pythagoras' theorem. Because it's the shorter side, we would subtract. It's not the hypotenuse, so we subtract. Square the two sides, subtract them, then get the square root of the answer. Second question could be answered a number of ways. It could be a trapezium if you turn it on the side, but that's not necessary. It's just the area of a rectangle and the area of a triangle. You can just add them together. It's actually no trigonometry really in this. It's just use of a triangle on top. Okay, on to the second page of questions. Okay, so question 3 here on top asks for drawing a chord. So I've just drawn a chord. It's a line that doesn't go through the center of the circle, but does go from side to side in a circle, so it touches two sides of the circle. And why is it 90 degrees? Well, that's one of our theorems on page 206, 207. You need to be able to recognize that, and it's because the angle is in a semicircle, so it's from a diameter. Okay. Question 4, rather, the first part asked us to find the actual distance, so that's done with a ruler, so I measured it with a ruler. Now I got 7 centimeters and multiplied it by the scale. You might get a different answer than that, but once again, as long as you show that you have measured and that is you've worked out using the scale, that is fine. As I mentioned in the lesson, part 2 measured the bearing from B to A. So that is starting at B, and what direction do I need to go? From A to B. So starting at A, what direction do I need to go? Well, it doesn't even reach 90 degrees. I measured it with a protractor. It's about 80 degrees, so in around that is fine. And to get to that, so I join them with a line. That's a good idea. Join them with a line. And then the last part is, so we had this other one I had to put in, C, and it's 120 kilometers. So first of all, I worked out what is that in centimeters by dividing by the scale. So I divided by, and I got 6. So 6 centimeters away from by B, and what direction? It's 300 bearings. That's right the way around, and it's just 60 degrees off a full circle. So that's why I have a 60 degrees here, and then it's that direction for 6 centimeters. So just measured that with a ruler. Question 5 then. Find the angle. So because it's the angle in a semicircle again, that top angle here is 90 degrees, and therefore just taking them away from 180 leaves me with 27. In the second part then, you would need to maybe I took that triangle out, or I just redrew it down here, and I noticed that it's just a sine, cos, or a tan. I've got adjacent, I've got hypotenuse, so I set up that's a cos. So I set up cos 63 of the angle is the adjacent side divided by the hypotenuse, and then rearrange so it's multiplying by that 12 instead of dividing, and I get 5.45. In this bottom question, it's another sine, cos, or tan. Find using a ratio. Once again, it's cos because we've got the adjacent side, it's alongside the angle, and we have the hypotenuse of 16, and we get 9.85. Moving along to question 7. So the first part asks for, the diagram shows a right angle triangle, and therefore they all add up to 180. We got a right angle there, so it's just subtract and we get 53. The second part then is to find an area of a triangle, so half the base multiplied by the height, so half 6.8 multiplied by 9, you get 30.6. And then the last part asks for the perimeter, which was tricky. You have to use Pythagoras' theorem to get that missing side. We need that missing side before we can add up all the sides. So 11.28, I found it out by squaring the two sides and getting the square root. And total then for the perimeter, 27.08. So I had to find that missing side, and then I added up the other two sides that I already knew, and that gave me an answer of 27. Question 8 then, what's that line called? It just clips off a circle. It's called a tangent. And draw on the circle a radius. So any line from the center of the circle out to the edge, would be a radius. So I just need to draw that. And then the diameter is the answer to question 9. It's just the diameter. One that goes through the center and goes to either side. If it doesn't go through the center, it's called a chord. And the last page. Okay, so once again, it is a sine, cos, or tan ratio. You got two sides and an angle, so you're going to use one of these ratios. It's the opposite side and the hypotenuse side, so it's sine. Sine of 35 is the unknown side divided by 16, and then rearranging means 16 times the sine of 35 gives 9.177. And the last question was another bearings question. So going from A to B, that's just 70 degrees. It's not quite 90 degrees, but it's 70 degrees. We put that as 070. If there's no 1 or 200, it's just 070, so it's just 70. So I drew that line in, that's my line. I drew it together, and then I measured that with a protractor. If you don't have one, you can estimate, no problem. And then it's the same as the one we did in the mini lesson. It's 8 centimeters. When I measured it with a ruler, I multiplied it by 5 because the scale is 1 to 5, and my answer is in kilometers because the answer is in kilometers. All right, so they are the answers to those practice questions. So I expect to see something very similar in the practice test when we do that tomorrow.